Morning, everybody. Let's get straight into where we stopped last time round and kick off with part G, excavations. You remember we dealt with F, or site operations, when and how much noise you're allowed to make and how much of a mess you're allowed to make. This is one of the more serious things. Excavations, not necessarily 100% SANS 10400 Part G applicable to contractors, but you'll see that the lawmakers have actually accommodated for that on the actual requirements of this document. So you'll see, for as far as building is concerned, that there are buildings that are there's work done on site that is exempted or that is dealt with by specific professionals. I would like us to go down to note 4, because that would be applicable to what we as plumbers do. Part G of the National Building Regulations, concerned with the safety or the stability of any property or service. The construction regulations issued in terms of the Occupational Health and Safety Act are concerned with the safety of workers during that same construction period. Part G is therefore concerned with the location and geometry, while the construction regulations are concerned with the actual construction of that excavation. So no, you don't need any more explanation than that. Important to note that the tendency has been over the last couple of years to do things more outcome-based, or to do them more job-specific. So if I could just move, there we go. If I could move on to this construction regulation of 2014, is actually a free PDF download. You'll see it deals with electrical tools, deals with various types of safety, transport of material, etc., etc. So as far as excavation for the plumber is concerned, a contractor, in other words, all of us, must ensure that all excavation work is carried out under the supervision of a competent person who's been appointed in writing for that purpose. Evaluate, as far as reasonably practicable, the stability of the ground before excavation. So the moment a contractor steps on site, is a responsible person, whether it be a terminology changed over the years. We had gang bosses, we had foremen, we had competent people, we had a whole lot of different designations doing pretty much that. A contractor who performs excavation work must take reasonable and sufficient steps in order to prevent, as far as reasonably practicable, any person from being buried or trapped by a fall or dislodgement of material in an excavation. He may not require any person to work in an excavation which has not been adequately shored or braced, provided that shoring and bracing may not be necessary where the sides have been sloped. It's a very practical document. It's not unreasonable requests, or it's not unreasonable requirements. And an excavation in stable material, permission's been given in writing by that appointed person after evaluating the site conditions, where uncertainty pertaining to the stability of the soil still exists. The decision from an engineer or a technologist competent in excavations is decisive, and such a decision must be noted in writing and signed by both the competent person and the professional engineer or technologist, as the case may be. In other words, it's not simply a case of, it looks alike to me, let's get into this, and then we're up and running. So we must take steps to ensure that the shoring is and bracing in paragraph B is designed and constructed in a manner that renders it strong enough to support the site. In other words, you can't just have a couple of pieces of branding holding a 4-meter deep trench open. It must ensure that no load, material, plant, or equipment is placed or moved near the edge of that excavation where it may cause a collapse. So you'll see it's all practical arrangements. It's no unreasonable request. You can have a look at this document. You can see it's quite a number of extracts from it. The requirements as far as working safely. Part G deals with the buildings. In other words, you won't undermine the foundation. We'll have a look at a couple of the requirements. But as far as the safety of the people on site are concerned, you'll see there's a whole list of requirements. Once you've read through them, you'll find that most of these requirements, or most of these bullets, are things that we do as a matter of fact every day while we're busy there. The problem normally comes in when you skip, or when you try and take a shortcut, or you don't have time to do something and something goes wrong. than these regulations, and you'll find that they're called regulations. In other words, they would outrank standard any time of the day. So definitely, if anything goes wrong, we'll go back to the regulation. So just a quick look at, we spoke, so let me just get my hand out here. Yeah. We spoke about proper bracing. You can work in that trench any time of day, any type of weather. At least you'll know that whatever happens down there will be happening in a safe environment. The reason I'm showing you this is that you'll see each of these pictures with that little tombstone sign on it. Someone got left behind. Someone never went home to their families. Someone somewhere was being held responsible for the loss of life. And if you look at some of these trenches and you imagine where people got caught doing a simple job on behalf of someone else or for themselves trying to earn a living, and you end up losing life for no legitimate reason whatsoever. Is a typical example of what we should not be doing. So, as I said, the construction regulations deals with the safety of the contractors and the people working on site. So if we go back to 10.400 Part G, there's a couple of simple requirements as far as the document and the building is concerned. So in temporary excavations, there's a simple rule that we apply. It's the 1-2 rule. So for every 1 meter you go down, you go 2 meters away. So if we look at the actual slope there, you'll find that that's the gradient going away from the foundation, which would simply mean that the further or the deeper you need to go for your trenching, or the deeper your trench needs to be, the further you have to be away from that foundation. If this encroaches on that area there and this foundation ends up slipping into that trench, and I've seen it happen, unfortunately. So you'll find that Occupational Health and Safety Act, it is for you to comply. This is basically what you need to do as far as your work on site is concerned. So there's a couple of other requirements as permanent excavations in that. Personally, 10.400 Part G, like the scope said, or the introduction bit said, pertaining to the buildings, I would not necessarily go out and buy this portion, because remember, each portion of 10.400 A to XA, you can buy individually. You don't have to buy the whole document. You buy the ones pertaining to what you'd like to do. So Part G is an optional one, but I would rather have that construction regulation one, which is a free PDF download, and you can reference to the actual requirements that you need to be aware of. So then we get to Part H, which is basically foundations. And then as far as foundations are concerned, we all know that there's the only time you get called back if there's a huge crack in the building, or there's something has moved, and then it comes back to the trench or the pipe. Or so if we had to go look at 10.400 Part P and 10.252 Part 2 for drainage, you'll find that those three details are the ones most applicable to us as plumbers. Whenever there's a pipe either crossing or penetrating a structural element, or whether it's found to be under, like in this case was penetration, under that structure, or if it needs to be removable afterwards, then we still need to look at these three options from 10.400 Part P and 10.252 Part 2 drainage perspective. The structural bit will be dealt with under Part H, which should have been designed, or which should have been dealt with at design stage. So as long as we make sure that none of our drainage gets caught in any foundations or point loads any of our drainage, then at least we know we're heading in the right direction. Part J deals with floors. It deals with floors in its entirety. So if we're looking at floors starting from timber, actual timber supports, the requirements for the floor itself, and then the use of, and we'll get back to these truss hangers or these hurricane clips. There are specific requirements for the use of them, and you'll see they're not exposed to elements. So very few of these standard brackets are designed for that use. Floor support, that would be your normal concrete flooring. and you'll find that it requires the concrete to be cube tested. In other words, the compressive strength after 28 days should be X amount per application, whether it be a floor, whether it be a foundation, whether it be a structural column. They all have their own requirements. So when it comes to plumbers and floors, etc., you'll find that there are more than enough tools of any size to make sure that we saw cut joints. We don't send a jackhammer through a floor without making sure that we prevent any breakages or cracks going up into the actual surface level of that floor. These are all done. You'll see B is structural. If you remember, B is structural and H. And most of the time, you'll find that a lot of these structural elements or part B comes back to the structural element. As far as the plumbers are concerned, you'll find that the requirement is that, yeah, you can see, I shudder to think what's happening under there, but this is the example that I've used. Polyolefin, which is basically a member of, or all members of the plastic family are joined under that, 250 micron, or Agreement certificate. So you'll find that there is the bottom end of the waterproofing. And the point I'd like to raise here is that penetration by pipes, plumbing fittings, or punctures that shall be taped with a pressure-sensitive adhesive tape approved for the use. In other words, if you feel, or if you have to have pipes in the floor, which is not always a perfect solution, but if you have to have, then make sure that those things are taped off and cleaned off and sealed so that when the concrete is cast, we don't have moisture coming back into your building. I've seen jobs where floors have been chopped up because of moisture, and the plumber gets blamed, and by the time the job is actually opened up, you'll find that it had more to do with groundwater than actual plumbing or potable drinking water being the problem in that case. So if we look at 10.252 part 1, pipes laid under walls and floors and surface slabs, which then ties in with the floors, where any portion of a pipe passes under a building or under a surface slab, unless otherwise approved, the following shall apply. It shall be installed inside a sleeve of a diameter at least 15 mm plus the outside of the pipe. The portion shall be protected against transmission of load. In other words, we don't allow things to bear on our pipework. And that portion shall be laid without any change of direction or without any junctions. In other words, straight lines, always. The trench in which such a portion is laid shall no way impair the stability of the building or interfere with any other existing services. So if we go to floors, the same thing would basically apply, or the floors, slabs, and walls, the same would apply. And then for the plumber's sake, we've got an example of a duct. Installing a pipe, you can either have a trench, or you could have a removable, or you can have sand with a screed, or you could have a cover. The main point I'd like to highlight here is you'll find that there's a sleeve. If that wall moves, or there's subsidence in the foundation and the wall, or there's movement on this wall here, we do not want any pressure put onto that water pipe. The same would apply in this case. You'll see that if you are going to be putting a sleeve under a building to get a pipe through, you'll see that this end needs to be closed off, not like these gentlemen forgot their stop ends. So you'll see that the moment the sand or the filling, or even when they cast the concrete sometimes, that concrete sludge goes into that pipe and it fixes that thing altogether. So having the sleeve there is basically nullified the moment they cast the slab. And then unfortunately, the same rules apply to drainage. It's not always adhered to, but here you can see a typical example of no change of direction in the floor. So you can imagine what a nice maintenance job that's going to end up being, going through 1, 2, 3 90-degree bends in one WC installation. Same thing with these waste pipes. So you see the requirements speak to each other. 10.400 part J speaks to floors. It refers to other requirements. And then when we come back to the plumbing standards, or our water and drainage standards, then we'll get back into having to deal with matters pertaining to building. So you'll remember when I started, I said the reason for looking at this building regulation, or this 3-part series around the building regulation, is to familiarize yourself with what happens on a building site. Not after the effect when someone's held liable, when there's a problem, but actually being prepared for what is going to happen or what you need to do on site before actually stepping on site. We get to part K. Part K deals with walls, everything to do with walls as far as you'll see it's got structural elements. I'm not going to bore you with all of those. Joints, and something that we sometimes get caught up with or that we get to deal with is that a vertical control joint shall be provided. So in other words, where buildings of different heights, different ages, if there's an extension being done, there are a number of issues that run across or that we use or that we have to deal with. That there is for movement. So if there's going to be movement and we are going to be putting pipes across that, you'll see when we get to the water bit, we're not allowed to do that unless we make provision for protection of that pipe. So when you're looking at walls, especially longer ones, they are, you'll see the builder would be forced, you get different types, columns, thicknesses, you can see even blocks. There's a detail for most of these things here, but there's a joint, pipe joint there with reinforcing. So there's allowance made for specific movement on all of these different shapes, angles. And this is pretty much, there's a typical example of a very nice movement there. And then you'll find that there's a definition that says it's a joint designed to permit relative movement of sections of structure or wall to occur without impairing the functional integrity of the building. So you can see these bricks ready to drop. They are pretty much part and parcel of what happens if there's no allowance made for that expansion and contraction. So we go straight back to the plumbing stand, or the drainage one and the plumbing one for that matter, where pipes pass through walls or solid floors. They'll be protected with a layer of inert material and be accommodated and sleeves that extend through the full thickness of that wall or floor. Drainage pipes should not be installed in a cavity or any cavity wall or pass through concrete expansion or contraction joints. So once again, the reference going from 1993 as far as the drainage standards concerned, right back to 10400 part K walls that says, please do not go through a expansion or contraction joint, because you will end up getting caught when there's movement or there's a pipe that pulls a joint or it starts leaking in a cavity, and someone needs to go and find that leak somewhere in whatever length of wall is being presented or is causing the hassle. Pipes installed in the dry cavity or cavity drywall shall be securely fixed. No pipe shall pass through concrete or expansion contraction joints unless provisions have been made for movement. In other words, there's the water back, previous one is the drainage, there's the water one back, and it does exactly the thing. Even concealed in reinforced structures, housed in sleeves, ducts, chases, laid in continuous lengths without joints or fittings, except where that joint or fitting is located in access port. In other words, in a duct or in an opening where you can actually get to that T-piece or that elbow or whatever fitting they're referring to. So yeah, you can see a typical example of, imagine once this floor is cast, we've got a joint into what looks like a vertical stack. So I can only hope this is not the highest floor. So there's a toilet and another toilet and a couple of waste fittings. So once this thing is nicely boxed in and it's concreted over, there'll be no access to any of those changes of direction, etc., etc. So it is something that gets overlooked by designers, something that plumbers end up having to work out for themselves or having to accommodate for themselves. But the reason for this whole series is to make you aware that from the structural side or from floors and walls straight through to our own plumbing standard, there's a reason why these documents talk to each other and highlight certain issues. Part L covers roofs. Roofs, when I say roofs, everything pertaining to roofs with regards to size, flat roofs, concrete, etc., etc. I'm just going to skip through to the bits that affect the plumbers. Construction drawings shall clearly designate ridges and valleys and state relative falls as shown. In other words, if you look at a building plan, it's a 2D drawing. There should be indications of where the valleys or where the joints or the actual upstand column beams, etc. will be. Penetrations through roof shall, as far as possible, be avoided and be located away from all low points. Such penetration shall not be flexible and shall be kept 200 millimeters away from all vertical, in other words, all beams. We don't chop pipes on beams or into beams. Plumbing pipes, electrical conduits, air conditioning pipes, etc. shall not be in clusters. So if we look at these examples that I've got on here, you can imagine this is one of those penetration areas where they've basically hacked the whole IBR sheet to get this pipe work going through there. So you can see it becomes a bit of a mess. But now the thing gets moved onto the contractor. The standard says you shall not put those things in clusters. You'll not demolish half the roof to get a pipe through there. And then no one says a word. The job is done. The roof starts leaking, or there's a, what do they call it? A weakening, or the roof structure itself degrades to a point where it actually collapses or it froths altogether. And you can see that back example there in the valley portion or in the lower portion where the water is supposed to move. So you've actually created a perfect storm right there to allow the water to get into your building. Here's the upstand. And then I think what we're going to do is we're going to look at timber roof is the one that we most often, or that we deal with most often, with regards to placement of geysers or geyser replacements. And you'll find that as far as timber is concerned, these are the standard sizes that are available. This is the latest one. There were a couple of sizes omitted through the years, but basically this is what you would be able to buy right now. So if we look at, we're looking at different slopes and material for those roof coverings, and we're talking about a Howie type truss, whether it be mono or double pitch. In other words, whether it goes one direction or with both. And you'll find that these trusses, those pitches will be higher to not accommodate any accumulation of the snow, etc. But if we had to look at a typical truss, that would be over the years, it's like an industry thing. The lower chord has been called a tie beam. There are different references to different specific posts, vertical risers, diagonals. You'll see this is the terminology used. So if we look at A as being an outside wall and we're looking at B as being the outside wall, that is the total span. The roof truss, or the strength of that roof truss, is born from a term called triangulation. In other words, the moment you have these triangles, and you can see there are quite a number of triangles in this little detail here. So that's where the strength of this whole truss comes from. So for you to be point loading anything in specific, years ago, we used to put wedges between the tie beam and the top of the internal wall to help carry or to help bear weight. Nowadays, with these designs on these lighter trusses, if you point load anything, you actually cause the truss to buckle, because you're taking that triangulation away and you're splitting a triangle in the wrong position. And just to finish off as far as this morning's concerned, Karim, have we got any questions?
We've got a hand that is raised. Lumkile, would you like me to? I'm going to try and unmute you to see if you'd like to ask your question. Yeah, you're able to unmute yourself now, Lumkile, if you have any questions.
Okay, while we're waiting for him, I'm just going to carry on. The spacing of trusses, purlins or battens for the different roof coverings shall be in accordance with the manufacturer's instructions or in accordance with table 4. So there's a set guideline on how to use it, and we'll get to the plumber's version of that. Very important, you'll see that all of these truss hangers, reinforced brackets, bolts, anything that you use on a roof, it is very clearly defined. You're using either a cloud nail, you're using a bolt with a square washer, you're using galvanized type truss hangers, we're using hurricane clips, and you'll find that metal masonry anchors shall be of the expanding type, be corrosion resistant, and have a diameter and a length of not less than 10 millimeter, and not shorter than 75 millimeter, and shall be installed in accordance with the manufacturer's instructions. So if we are going to be working on stands or bolting things together to get geyser stands done or to get normal tank stands done, it's important to note that as far as the details are concerned, I'm going to skip through the actual bracing because we shouldn't be cutting any of that. To get to 10254, there's a very specific detail of how to, there's one for perpendicular to trusses. In other words, only 3 trusses per, one geyser per 3 trusses. So you see one additional bottom chord. So that's been reinforced, and the details are all part of what we do in 10254. You can see there's one that runs parallel to the trusses. So it's got the same additional bottom chords, the same requirements, the same nailing, the same support for geysers. We jump to the solar one. The solar standard from 2014, exactly the same. We have got all the requirements for the different ones. Each one of them you'll see says anything over 250. You need to consult an engineer for that roof because you're starting to point load and you're starting to put additional load. And this detail may not be applied in hips or valleys. So we don't jump onto roof joints where they've already been weakened or reinforced to a point to carry the roof. Still in 10.10.6, we have got integral systems. So you'll find that there's bigger timber reinforcing required there for the actual geyser. The sizes are all on there. Everything is specified to the details. Then there's a standard called 10243, which is the construction and erection of roof trusses. They go into more detail. This document goes into more detail, and you'll find that it actually shows you where your nail or your bolts should go, where you need to put the hurricane clips to support the additional timber that you're putting over that portion. It goes into great detail to make sure that when we do an installation of a geyser, we do not weaken the design, or we don't weaken the actual design of the trusses. The same thing for perpendicular. And I just want to get to this table here. This is from 10243 of 2004, and we spoke about this table earlier. So you'll see it starts with the geyser capacity, in other words, what geyser you're putting in, and then it tells you what the load is, and then we go to tiles being at 750, 1 meter being your normal 76 by 50 purlins on either light sheet or similar roofing, and then 1500 we go to total lightweight frame. So you can see if we had to put a 150 liter geyser at 750 centers, we need 38 by 114 would be your additional support. So there's documentation of this available all around. You can see this is quite a nice job. It's been doubled up, hurricane clip. There's no ways that the weight of that geyser and the plumber and whoever goes into that roof with that geyser and water in there will be able to damage that specific roof structure. Here's another nice example of what it should look like. And then before we close off for the morning, this you can see is what we do not want. Definitely unacceptable. And this is what happens if we don't do what the requirements require. But I have one that would actually beat all of that. So there you can see this is what happens if you leave and non-qualified or non-properly trained individual to do installation in the roof. You see they've cut that whole bottom chord right up to the batten that carries the ceiling boards. So that roof truss has come and gone. You can see the weakening on the middle one, and then you can see here that whole triangulation portion of what was supposed to be the support in this truss has been cut away to accommodate this installation. So you can see there's quite a bit of negativity around these specific installations, or when it comes to roofing, because we have got guys that sign off on roofing as professionals. So next week week after next, we'll do part 3 and we'll go through the last bit. I hope this was informative. If there's any questions, don't hesitate to post them. And I see there's something there now, Karim?
Yes, there's a comment from Emil. With the new way of building, where all waste pipes are concealed, the designers do not take these standards into consideration and make work very difficult for plumbers. So many joints, concrete slabs, and walls.
Indeed, very correct. The downside to that whole design process is that when the professional submits that drawing to the local authority, he actually signs a document to say that his whole design complies with a complete set of 10400. In other words, part P that we'll look at next week. It also requires the same thing for floors and walls, etc. So yeah, it's a definite issue. But the more experienced guys or the construction guys will tell you that these types of things actually get resolved the moment you get onto site and you have a viable solution. You can then propose that and rather do it the right way. Yes, but cognizance taken of the comment, and it is a common problem. Look forward to seeing you guys in 2 weeks. Keep well, keep safe, and keep doing what we do properly.